Today, I'm presenting a research about vector graphics generation with large language models and generating vector models, generation vector images with AI models remains an underdeveloped field of research. And recently, large language models have made huge improvements in different domain tasks. And the idea is that by encoding vector images as SVG source code, they can be processed by LLMs. This research answers two questions, evaluates two questions. So the first is the task of SVG generation with LLMs, specifically by GPT 3.5. Which will be referred as ChatGPT and GPT-4. And the second task is object recognition from an SVG image. So the module is fed with an SVG source code of image of some object, and so then it tries to guess what is the object. Two methods were evaluated and compared of generation of imagery. So the first method is generation from prompt. So the model is just prompted to generate an image of an object in form of SVG. And the second technique is firstly generates the object in form of ASCII art, and then converts this ASCII art into SVG source code. So as for the SVG generation from prompt, prompt engineering techniques were used because ChatGPT was constrained from generation of SVGs. And then master prompt, so-called jailbreak, was used to force it into generation of source code. Interesting fact that this constraint in GPT-4 has been removed. There does exist some related research on the topic of generation of vector images with AI models or different forms of processing it. For example, Sketch RNN and ClipDraw implement text-to-vector image synthesis. Models such as DiffVG and image-to-markup vectorize raster images. Live module vectorizes raster images layer-wise, which can be very useful, for example, for generation of emojis, of icons, of different clip art, and different UI elements. DeepSVG generates animated vector graphics, and there is currently no scientific research about generation of SVGs with large language models. Only a few blog posts exist on this topic, and we'll talk about it later. Let's dive into the experiments. So firstly, some experiments were performed with the GPT 3.5 model, ChatGPT. It is capable of generation of simple geometric figures such as triangles, circles, squares with some predefined constraints such as width and height, stroke, thickness and color, also fill color. Here you can see an image which was generated by prompts generates an SVG image of blue circle with black outline, and it is indeed a blue circle with a black outline. Then more sophisticated experiments were conducted about objects, simple objects consisting of multiple geometric shapes. And three shapes were chosen, ascending by complexity: a banana, a Christmas tree, and an automobile. Here we can see two distinct templates of prompts which were used. The first type of prompt was just a very short and basic prompt, and the second template of prompt was trying to explain which elements should the object consist of. And here you can see on the left, on the top, you can see a Christmas tree, a banana, and an automobile generated by ChatGPT with a simple prompt. And in the bottom, you can see them generated with a detailed prompt. So the banana doesn't look much like a real banana. The Christmas tree is somewhat recognizable, and the automobile is also somewhat recognizable, but it is very, very oversimplified. And the next experiment conducted was trying to generate a complex object. And in the role of a complex object, a cat's face was chosen. And the first iteration was very messy and almost unrecognizable. Here you can see it's in the top left corner. And then ChatGPT was prompted to fix mistake with specific instructions, such as creating a closed shape around the face elements, moving face elements in different directions, etc. And here we can see that ChatGPT has not been able to make the corresponding changes to the image, rather generating different variations with a lot of differences. Yeah. Then the same experiments were repeated with a neural model with GPT-4, and there is no need to talk about simple geometric figures because it was as successful as the previous model with them. And about the objects of multiple simple geometric shapes, here you can see the same bananas, Christmas trees, and automobiles. And so you can see that the Christmas tree and the automobiles look a lot better. And some examples are quite sophisticated. For example, the second automobile from the left. And here we can see that GPT-4 definitely outperforms ChatGPT in this task. And the next experiment concluded was trying to draw a complex object, a cat's face, and GPT-4 outputs hardly recognizable results at first. You can see them in the top left corner, but it performs much better in the task of correcting the output according to the prompts. And during 12 iterations of prompting with prompts like creating a closed shape around the face, moving face elements in different directions, drawing eyes, and changing the number of whiskers, you can see that finally it was able to create a recognizable cat's face image according to the instructions. And the next experiment concluded was generation of ASCII art with subsequent conversion to SVG. ChatGPT didn't handle this task quite well, so the cat's face ASCII art and its conversion to SVG are hardly recognizable and very simplistic. GPT-4 was more successful in this task, generating a more recognizable ASCII art and a more recognizable cat's face. But comparing this to regular generation with prompting, these results are worse. The conversion to SVG is not strictly conversion, but rather an interpretation of the ASCII art, because you can see that it differs by a large margin from the original ASCII art. The next task which was evaluated is recognition of objects on SVG images, and 3 images were chosen. ascending by the complexity, a smiley face, a cat silhouette, and a house. And as for ChatGPT, the model correctly recognizes the face, and it was not sure about the cat. It told that it could be any number of four-legged animal, and it recognized the house as a house with an arrow. And GPT-4 was even more precise about the face. It provided a detailed description of the face elements and corresponding SVG paths for these face elements, but it did mistake the cat with a rabbit or an elephant, and it recognized the house as an open folder icon. In conclusion, I would like to say that large language models have not been specifically trained to work with SVG, but they do achieve some early but promising results in the fields of SVG generation and SVG object recognition. And currently, their SVG processing capabilities can't be used in real-world application due to the primitive and messy output. But they are currently able to generate primitive SVG graphics and even make changes to these graphics according to the prompts. And we can be pretty sure that some progress is being made, because GPT-4 definitely outperforms ChatGPT in all these tasks. And of course, future iterations of large language models will be even better in all these tasks, and future research should focus on enhancing the model's abilities to recognize and generate even more intricate vector images. Here you can see the list of reference. Thank you for your attention.
Boris, thank you very much. And we have time for questions. So please also in Zoom, you can also ask questions if you have any.
Thank you for the presentation. What do you think? How do you think the I don't know, next generation of GPT, let's say GPT-5, would outperform the GPT-4 in the SVG generation task?
Thank you for your question. Interpolating the progress that has been made between GPT 3.5 and GPT-4, I suppose that keeping in mind that it probably won't be specifically trained for this task, future generation models would be able first to generate more complex and more accurate results. So, and secondly, they will be able to change the output, to manipulate with it even better.
Thank you. Have you studied the ability of those models to generate a really large amount of objects? Like you tried to generate the face, the cat, and so on. Have you tried like 1,000 of objects to generate and look at the ability?
Do you mean drawing a scene with a lot of different objects?
Yeah. No, not with multiple objects, but just one object, like not just a cat and cat on or face, but I don't know, chair, person, microphone, door, like this.
Do you mean generation of complex objects?
Yeah. Yeah.
I didn't actually. I tried generation of some more complex objects, but the model outputs a very simplified and very primitive image. And if I ask the model to improve the results, to add more details to the image, and when I describe the details which should be added, the model tries to do it, but actually it fails, and it indicates that it can't handle objects of such complexity in the output.
Thank you.
Thank you for your talk. I have a similar question. Do you have any ideas how to enhance the model ability to generate images, or do you just check how the models do it?
I didn't quite understand your question. Can you reformulate it?
Do you have your own ideas how to enhance the model abilities to generate SVG images?
I think the main ideas which could be useful in this field would be specifically training the model to accomplish this task. And this training, it can happen, I suppose, even with prompting. So, for example, we can do some automatic prompting, which should, in theory, like explain to the model more about this task.
Okay, thank you.
Thank you for your talk. I have a question about the experiments. When you describe the prompt, you put only the high-level descriptions of what you would like to see on SVG, for example, cat, without descriptions of visual representations. For example, have you tried to explain the model how exactly should cat look like? Like it should has ears, some kind nose, eyes, and so on. Have you tried, for example, to put it into ChatGPT?
Yeah, of course I did. So actually, the results of such prompting for ChatGPT, it actually tries to implement all the details from the prompt, but it fails on a very early stage. So it works with geometric primitives. So when manipulating geometric primitives, I can ask ChatGPT to add more details, like, for example, draw a circle inside a triangle, and it will accomplish this task. But if I try to manipulate with more complex objects, ChatGPT fails. And GPT-4 performs significantly better in this task. Let me show an image. So when I was prompting this cat's face, I asked the model, for example, to add the black circles inside the eyes, to change the number of whiskers, and it was successful in doing this. Yes.
And what about ChatGPT? It was not successful.
Yeah, it was not. So when I was trying to do the same with ChatGPT, it just outputs some messy drawings. So they were not adequate to the prompt.
Thank you.
Any more questions from the audience or online audience? If not, I will take my turn. Okay, let's just dive into how we can improve it. Actually, at this slide, you were evaluating if it looks like a cat or not by yourself.
Yes.
And I believe it can be automated. So we can just download an image and use some image recognition network, which could tell us if it's a cat or not. And those we can validate if a series of prompts you have used to generate it is valid or not. And this can be used to build up a pairs of, let's say, image, which is automatically recognized as a cat, and the corresponding series of prompts. So we can build up a data set which somehow learns to, I mean, it's not learn, which somehow represents a visual description of an image of a vectorized cat. So, and by constructing this data set, we can use it not each by each picture, but do it in a more automated way to build many images. So then we can train using this prompt. We can do training via prompt engineering, let's say GPT-4, to understand visual things about not only exact images, but in general. And hopefully it can generate something new, even without such complicated prompts.
Yes, actually, this idea sounds like a very good path for the future research in this area. And I think that it's worth trying to implement.
Okay. The second question is about ASCII. Could you go to the slide?
Yeah, of course. You mean first or second?
Any. Actually,
Okay.
I'm really surprised when I read the results that it still somehow can understand how to generate. Okay, let's be clear. It's not a cat, but it's something looking like a cat.
Yeah.
Do you have any ideas how the model can understand that this textual sequences looks like a cat?
It's a very interesting question. I think that maybe there was some ASCII art in the data sets which the LLMs were trained on, because a lot of ASCII art exists on the internet. And actually, while Googling for ASCII art of cats, I have counted at least several thousands of different drawings. And I think that this could be helpful for the model to understand it.
But I still don't get, because actually we need to make a 2D positional encoding of the text. So it should know that these brackets should be like exactly in this position, not left or right, which seems to be quite complicated for transformers.
Yes, it seems like a complicated task, and actually I have no idea why it does work even in this simple way.
Yeah, but it still looks very promising, because these dependencies are quite complicated to be modeled with without like more complicated positional coding. So either the positional coding is quite complex, or they do it like in a more complicated way than at least I imagined.